Section 6.2.17. A binomial probability experiment is conducted with the given parameters. We're going to compute the probability of X successes in the n independent trials of the experiment, where n is equal to 10, the probability is equal to 0.55, and X is equal to 6. Okay, first let's recall that the probability of obtaining X successes in the n independent trials of a binomial experiment where the probability of success is P is given by the following formula. We have the probability of X, which is 6, is equal to, this is n, which is 10, the combination of C where X is 6, the probability is 0.55, and we plug it into this formula. Now recall that this combination, we know that n combination X is equal to the following formula. That is equal to n factorial over x factorial times n minus x factorial. Okay, so let's first go ahead and write down our information. We know that x is equal to 6, so we have p of 6, which is equal to the value of n, which is 10, and then combination x, which is 6, times the probability of 0.55 raised to the power of x, which is 6, times 1 minus p, which is 0.55, to the power of n, which is 10, minus x, which is 6. Okay, now for step 2, again, we have the probability of 6, and then we use the formula n factorial, which is 10 factorial, over x factorial, which is 6 factorial, times 10 minus 6 factorial. And then we're going to multiply that by 0.55 to the 6th power, and then we're going to multiply that by 1 minus 0.55, which is 0.45, and that's to the 4th power. Okay, so again, we're doing this by hand, so we want to again find the probability of 6 here. So the probability of 6, we're going to put in this 10 factorial. So let's go ahead and do that. So we can go ahead and put in 10 math, or we can just go ahead and do the formula n factorial 6. So we can put in 10, and then go to math, and then go to probability, and do the NCR. And then we're going to put in the value of 6, and therefore that gives us 210. So we know that this first number is going to be 210. Okay, and then what we're going to do is we're going to take 0.55 and then raise that to the 6th power. Okay, and that gives us 0.2768. So 0.02768. And then we're going to take 0.45 and raise that to the 4th power. And that's going to give us, rounding that to, again, 5 decimal places, is 0.04101. So therefore, we know that the probability of this value, we're going to take this number. Okay, so we got 0.04101 times 0.02768 times 210, which gives us 0.2384 rounded to 4 decimal places. So we get 0.2384. Okay, now this is it doing it by hand. All right, now let's say that if we want to use the TI 84 calculator. Well, we're going to use the binomial PDF. PDF meaning that is the exact, meaning because we have equals. So we're going to use the function binomial, or binom PDF, where you have n trials, you have your probability, and then you have the value of x. So we're going to go ahead and put in binomial PDF, where n is 10, our probability is 0.55, and the value of x is equal to 6. Okay, so using our calculator, we're going to go to second and then distribution, and then we're going to scroll down to where we see binomial PDF. And again, P stands for when you have x is equal to something. Right below that you have C, which means whether you have a less than or equal to, and we'll talk about that in another problem. So go ahead and hit enter, and the number of trials is n, which is 10. The probability is 0.55, and the value of x is 6, and then we're going to paste it. So we're going to paste it exactly the way you see it here. So you have binomial PDF, parentheses 10, comma 0.55, comma 6, and then we get the value of 0.2384 if we round it to 4 decimal places. So we get 0.2384. Okay, so that is using the calculator. Now, if I wanted to use StatCrunch, then what I'm going to do is the following. I'm going to go to StatCrunch, okay, and I'm going to select Stat. I'm going to go to Calculators, and I'm going to select Binomial. Okay, so at this point here, okay, we're using the standard. Okay, we know that our number of trials is 10. We know that our probability is 0.55. And then we want to use the equality because, again, it says x equals 6. So we're going to select the equal sign, and we're going to put the value of 6 in there, and then we're going to hit enter. And I'm going to go ahead and we compute that, and I'm going to copy that so we can see what that looks like. Okay, so for StatCrunch, you can see that we get the same result. So if we round that to 4 decimal places, then we get 0.2384. Okay, so we can see if we do this by hand, which you still want to know how to do, you can use the TID4 or StatCrunch. And so the conclusion states that, therefore, the probability of 6 successes in the 10 independent trials of the binomial probability experiment is 0.2384.